Hello, geometry students, and welcome to our final section in Chapter 5. We wrapped it up kind of quickly, but we are working in Section 5-6, and we're talking all about inequalities in one triangle. So what I'd like for you to be able to do by the end of this lesson is to be able to use inequalities based off of properties that I'm going to be telling you about to solve for angles and sides of triangles. All right, so let's get into these two facts that we're going to be applying in our lessons today. So the first fact is the largest angle lies opposite of the longest side. So if I were to draw an image of that for you, let's say that we have a triangle right here. And it's very obvious that this angle is the largest angle. And notice how it's on the opposite side of the triangle where the longest side is. Right there is clearly the longest side of that triangle. So that's all that's saying. The largest angle is opposite of the longest side. The next fact that I want to tell you about involves the sums of the side lengths. And this is the sum of two of the side lengths I'm going to say of any two. Of any two of the side lengths of a triangle must be greater than the third side. So let me show you why this is necessary. So let's just pretend that we have a triangle and this side is side 100, and then we have another side that only has a side of 10 and another side that has a side of 15. Well, notice that no, I cannot get these two endpoints to connect. Even if I were to push them closer together with smaller angles, this side length of 100 is so long that these two have to thus be longer in order to compensate for that length. So if I added 15 plus 10, that would get me 25, which is not greater than 100. So here, the sum, or when we add up any two of the side lengths of a triangle, it has to be greater than that other side. And this is an example as to why we need that, because if it doesn't meet this requirement, then it will not be a triangle. Okay, so let's start putting these two properties into action. So in the first example, it says, write the angles in order from smallest to largest. Write the angles in order from smallest to largest. So remember, the largest angle lies opposite of the longest side, so we can also then say, oh, the smallest angle is going to lie opposite from the smallest side. So just looking at our side lengths, notice how 17.2 is the smallest number. That's this side right here, GH. So opposite of GH is angle F. So I'm going to say angle F, and I'll write smallest to largest just so we can see the progression and we know what direction we're going. So this right here is the smallest side, so it's opposite the smallest angle. 19.6 is the next smallest side. It's the one that's in the middle of the side lengths. Opposite of it is angle H. So then I'm going to write angle H. And finally, I have to be left with angle G. That's the only option I have left. So I'm going to say angle G. For problem B, it says write the sides in order from shortest to longest. So now I'm going to use angle measures to order the side lengths. Before I used sides to compare angles. Now I'm using angles to compare sides. But first, notice how I have a missing angle. So I need to figure that missing angle value out. So I'm going to add 72 and 60 together, and that's going to get me 132. Then I'm going to take 132 subtracted from 180 because I know that the three angles inside any triangle add to 180. So that is going to get me 48 degrees. So now I can put in a 48 degrees right here because now I know that this angle must be that, so all three of these add to 180. Okay, so now it says write the sides in order from shortest to longest. So I'm going to write shortest to longest. So now I need the side opposite the smallest angle. 48 is the smallest number. The side opposite from that is PQ. So I'm going to write segment PQ first. Then I need to go to my next smallest angle. So 48 would then go to 60 because 60 is less than 72. So opposite from the 60-degree angle is QR. And finally, my largest angle is 72. The side opposite from 72 is PR. And there we have it. That was using our first property. The largest angle lies opposite of the longest side. Now we're going to use that next property about the two sides having to add up to more than the third. So it says, tell whether a triangle can have side lengths with the given lengths. Explain. Okay. So the way that we do this, we have to set up inequalities. We have to take two of my side lengths and add them up to see if they are greater than the third. So two of my side lengths are 7 and 10. So I'm going to say 7 plus 10, and I'm asking myself, I'll just put a blank, is that greater than 19? Is it? No. No, it is not. So 17 is not greater than 19. Because this does not meet this requirement, I have to say no, they do not form a triangle because 19 is greater than the sum of the two other sides. So that's for problem A. It cannot be a triangle because 19 is greater than 7 plus 10. Okay, so we are done with that one. Let's go on to example B. Example B has side lengths 2.3, 3.1, and 4.6. So let's add 2.3 and 3.1. And we want it to be greater than 4.6. So 2.3 plus 3.1 is going to be 5.4, and 5.4 is greater than 4.6. So yes, that works. I'm going to compare again. Now I can add 2.3 and 4.6, and I want to know, is it greater than 3.1? Okay, well, 2.3 plus 4.6 is 6.9. 6.9 is greater than 3.1. Awesome. So now I have another side or another pair of sides that's going to work. Now I need to add 3.1 and 4.6. Is that greater than 2.3? Well, we know it's going to be because both of them are larger, but I'll still work it all the way out. So that's going to get me 7.7 is greater than 2.3. There we go. So notice how all three of my inequalities, the two sides getting added together is greater than the third side. So yes, they form a triangle. For example, C, it has side lengths n plus 6, n squared minus 1, and 3n when n equals 4, sorry. All we have to do is take this n equals 4 and substitute it in real fast. So this is going to be 4 plus 6, or 10. This is 4 squared minus 1, or 15. And 3 times 4, or 12. So all I did was take this n equals 4 and substitute it into each of my expressions, but because it was such simple mental math, I went ahead and did it in my head. So now I'm going to set up these inequalities once again, and I'm asking myself, is 10 plus 15 greater than 12? Well, 25 is greater than 12, so yes, that one works out. Is 10 plus 12 greater than 15? 22 is in fact greater than 15, so yes, that one works out. And then I need to add 15 and 12. Is 15 plus 12 greater than 10? That would get me 27 is greater than 10. So yes, that is true. So that means, yes, they form a triangle. So this example was using the second rule that says the sum of any two of the side lengths of a triangle must be greater than the third side. We're actually going to be using that property in example 4 and 5. For example 4, it says the lengths of two sides of a triangle are 8 centimeters and 13 centimeters. Find the range of possible lengths for the third side. So these are our options. Either 8 and 13 are the long sides or they're the short sides. So it's up to us to figure out the upper boundary and the lower boundary. So if 8 and 13 are the long sides, then we need to find a shorter side that could be the third one. So that means I'm going to take 13 minus 8, and that's going to get me 5. So the smallest side must be greater than 5. If these are the long sides, this is a very heavy if. But what if 8 and 13 are the short sides? Because there's a lot of way that we can draw a triangle with a side 8 and a side 13. Like, they could be really far apart with an angle, or they could have a really narrow angle. So we're figuring out all the possibilities. So now I'm going to add them up. 8 plus 13 is going to equal 21. So this would be the longest side if these are the short. So now I have my range. It must be between 5 and 21. So 5 is going to be less than, I'm just going to say x for the unknown, which is going to be less than 21. X has to be in between 5 and 21 because we just said the smallest side has to be bigger than 5, and the largest side has to be no more than 21. If it were exactly 5 or exactly 21, then it would not be a triangle. Example 5 is just like the previous one. It's just now that we have a little graph. So it says, the figure shows the approximate distances between cities in California. What is the range of possible distances from San Francisco to Oakland? So first of all, not drawn to scale. That's important for you to know. Pictures can be very misleading, so don't just assume, oh, it must be 10 or something like that. That's not the way that works. So we're going to set this up the same way that we did our previous problem. What if 51 and 46 were the long sides? I'm going to take 51 minus 46, and that's going to get me 5. Or they could be the short sides, so I'm going to take 51 plus 46, and that's going to get me 97. Now I have my range. The shortest it could be is 5. The longest it could be is 97. So I'm going to say 5 is less than x, which is less than 97. And we're working in miles. And that's all for today. If you have questions, bring them to me tomorrow in class, and have a good night.